as a moderator for the first time. Thank you, Lynsey.
Thank you, Elaine, for your kind words. Good morning, everyone. Welcome to our panel session on building the networks of tomorrow, which is a topic that's as wide as the ocean, and we need to cover it in 40 minutes. So we're going to crack on through. We're very lucky to be joined by an illustrious lineup of panelists today. We have Steve Alexander from Ciena, Andrew, just in time, the magic of Ciena. Andrew Hankins from Telstra, Tim Stutch from Facebook, Masato Hoshino from Colt Technology Services, Somesh Gaur from Tata Communications Transformation Services, and Nanang Hendarno from TELIN. So welcome to our panelists. We're going to crack on straight. We're going to start with the Subsea system. So Tim, what technology is key to Facebook's network design plans for the next 2 years, 2019-2020?
Okay, so we'll start with the things that we've been putting into ITTs today and actually over the last, say, 9 months to go into production in 2 to 4 years, depending on where it's at. And there's a handful of items that started out as options. So we asked for like a multi-fiber, high fiber count option compared to a lower fiber count, high top, what you would traditionally call a high power nonlinear system. Those have proved out in a number of cases already as the optimal solution from a cost per bit perspective and also for a total capacity perspective for the cable. So you end up with a large capacity for the cable at an incrementally small cost in comparison to a high output power repeater based low fiber count. We've also done a lot of analysis to make sure that jives with buying a large number of transponders. In almost every case, all the cases, if I do a higher fiber count cable and I purchase more SLTE transponders, I end up with a higher capacity for a lower cost per bit in every single case that we've analyzed. So that's really what we're pushing right now is higher fiber counts. So 12 or 16, we want to see more than that, ideally. And there's two things that come with it. One is that the idea for this is that we're electrical power constrained for the system. So we're really trying to figure out how do we add more power to the repeaters, be it through higher amperage from the PFE or better electrical efficiency, electro-optical efficiency in the repeaters. So that's something else that we're trying to drive forward to get a better envelope, to get more capacity. And then the last bit is that we're operating in a linear regime, not a nonlinear regime. And that changes a little bit of the complexity that you need to have in the modems. So I won't say that we've been pushing that yet, but there's some trade-offs there to be handled. So ideally, high fiber count, lower power, higher capacity. And then the last thing is that we really look for an ability to partner well because we need to meet our capacity and availability needs, but typically we're not the only party involved. And I think that approach gives you a much more granularity for having maybe a few more partners that have more modest demand requirements to allow you to get into places that would be more challenging if they would need to buy half of a C+L system.
And just to ask, if the focus is on SDM cables, do you see the place for C+L within parts of your network?
So the challenge for C+L, it proves in at a slightly different point than the multi-fiber count. Where it becomes challenging is, let's just take a 8 fiber count C+L system with four partners. Everybody gets 2 fibers. They're really big in terms of capacity. So each partner needs to want to have a demand set that's similar or scales that way. That becomes challenging to try to sell 40 terabits to someone when they only need 10. But if I do a 12 cable or 12 or 16 fiber system, and each fiber is doing 12T, and they need 10, they might be willing to go to that one, take one out of the 12 or 16. It becomes an easier economic prove-in for them. So I think it opens up the door a little bit for more partners.
Thank you. And Andrew, Telstra partners with Facebook on the HKA cable. Can you tell us a bit about the design of that system, in particular the use of the ROADM BU?
Yeah, so for HKA, it's going to be the first time we use WSS ROADM. For us, the major driver for WSS ROADMs was the cable, I think this was explained yesterday, is predominantly running from Hong Kong to the US. We're also going to do a branch landing into northern Taiwan. And so we have see demand from both Hong Kong and Taiwan to the US, and having a WSS ROADM allows us to granularly change the split of capacity to Hong Kong or to Taiwan to the US. The second use for us is we have a cable C2C landing in southern Taiwan in Fangshan, which is not impacted by the sort of subsea events that happen in the Luzon Strait from time to time. And we've built an overland fibre route from northern Taiwan to the south, which means that we can also reroute traffic in the case of a failure event between Hong Kong and Taiwan to route traffic from the US to Taiwan, overland across Taiwan, and then from the southern Taiwan to Hong Kong, just to provide additional diversity, which is fairly unique, basically.
And how much of your network design is driven by customer requirements as opposed to the necessity to optimize your cost? And that's a question to everyone, really.
Yeah, cost. Look, at the end of the day, we're building our network for customers, so that is the primary driver. Is the customer requirements, customer demand. Of course, if we really think we understand what our customer demand is for the next 25 years, we're kidding ourselves, which is where we need that flexibility to adapt to demand. And optimizing cost, that comes back to just, is the case viable? How do we make it viable? So it's always a play off of the two factors. How do we create something unique, create differentiation without unduly adding to the cost?
Anyone else like to comment? No.
Yeah, so I mean, I definitely agree with Andrew. I mean, all of our demands at Colt are obviously driven by the customer. Cost optimization is really a subset of what kind of daily things that we do. Obviously helped by the technologies that are driven by some of our partners like Ciena. So I mean, it's really based on where the demand is from our customers and some of the key data centers that we need to get to.
Thank you, Masato. And thinking about operations of the network, we all know it's difficult to integrate new technologies, WSS, ROADM, BUs, Spectrum, SDN, into existing networks and new networks. Somesh, what do you see as the challenges and opportunities within your network for this?
I think to just give you a background, the way software is changing the world, everything is getting controlled by the software, and which is leading to the changing in the traffic patterns, and new services are getting and because of that, I think the submarine networks also, they need to change accordingly, and they should also be controlled by the network, by the software. And what is happening is that this will lead to the easy manageability of the software submarine network. And also, that is not just the end thing. The basic thing that we are looking at as an operator is the openness of the cables. And this is where I think SDN can help. And also, if the cables are more open, then the SDN will be really, really useful for the operators. Second thing is the collaboration between, within the, services. Whenever we have multiple services, we should be able to use the underlying network in a very well way. And we have also we are also expecting basically the convergence of the terrestrial network, the submarine network, and also the multiple network. So that will lead to the easy manageability of our network. And not only that, what happens is there are multiple vendors in the subsea. And unless until there is a collaboration between the vendors and we are able to manage it in a single way, we will not be able to get the benefit of the SDN in a proper way. All these factors, whether it's openness, whether it's collaboration, and also to add to the innovation, that is all required unless until we want to use the SDN in a proper way. So,
thank you. And so, Steve, how are the vendors going to help us overcome all these issues with new technology? Potential issues.
So I'd say I think we're going to be working in three areas. One would be kind of I think what everybody would expect, right? Better spectral efficiency with the modem, right? If we can do kind of 4 to 5 bits per second per hertz. We'll do 5 to 6. I mean, it will progressively get better. We just all have to realize Shannon is out there, right? So there are some limits, and that's just the way the physics works. But you can clearly look forward to us continuing to push that technology. You know, it will be done in a couple different ways, not just spectral efficiency, but power consumption, size. You know, you'll be able to find that basic coherent technology consumable in a lot of different ways from us. So that's one area. I think the second one, and it's a little, maybe arguably a little bit more subtle, is going to be this transition from what I would call system think to network think. And I'll point to the fact you named the panel here a network design panel. And the reason I say it that way is systems, when you say to someone, this is a system, you typically think of it as a closed thing, right? I bought a system. When people think of networks, they typically think of things being open. And one of the transitions that this industry is going through is that boundaries changing, right? The system used to be, you know, years back it was beach to beach, it was the drop side of the SLTE. That's no longer true, right? The system definition has changed. The system's the cable, and we've moved to an open architecture, right? So we're opening those sorts of things up, but it's that concept of, hey, systems are closed, networks are open, and the boundary is moving on us, and I think actually that's very good. That's why the internet works, that's why Android works, you know, those are open kinds of architectures. So that's the second area that we're going to be continuing to push on. The third one is going to be the network intelligence piece and the adoption of programming interfaces. I had it in the talk yesterday. You've heard it kind of sprinkled through various presentations here. You have to have a well-defined programming interface to the components that make up both your network and your system. In the networking space, people typically throw around terms like netconf and yang, right? If you want to get your arms around what that means in some sense, you can say netconf is kind of like we've agreed on the language. Like we're all going to speak English, for example, right? That's an agreement. But you still have to say what the sentence structure is. What do the strings of words mean when you put them together? And that's kind of the yang piece of it, right? So you've got to get that agreement established as well amongst all the vendors, all the participants in the ecosystem. Once that's done, then you get a lot of creativity because you can start to put things together differently, like Legos, and you can make a lot of different things out of Legos if you're creative, right? So that's the way that we're going to be pushing it is, you know, continue to improve the physics the best we can, right? That's going to be driving for best performance. Move us from this kind of system think to what we would call network think, and then the ideas of all the open interfaces and APIs. I think those are the three big areas that I think you can look forward to us contributing in.
Thank you. And thinking about the network and not just the subsea system and the terrestrial system separately, do we see more opportunity, I'm thinking on the supply side, for partnerships or for a more disaggregated model across the network?
I think partnerships kind of come naturally. I'll point to the one that we did with TE Subcom. Why did that get created? Is we had a shared vision of open architecture cables. You look at it and you say, okay, they were kind of the first in line to say, hey, we should open up the architecture because goodness can come from it. But kind of inherently, well, they're open now, so we can partner with other folks, right? So you're going to find these alignments of vision that I think come into the marketplace, and there's also then you get what effectively are alignments of need. Somebody's got a problem, we've got a solution that can form a pretty tight bond. So I think you're going to see those, you know, pairwise things start, and then you get a little ecosystem that builds up around it, and over time, that's how the business continues to thrive.
Yeah. Thank you. Moving through the network, because we all need to reach our end users, looking at Metro, with compound annual growth rates of 50 to 80%, Masato, how do you design your network to meet your customers' bandwidth needs?
Sure. So I guess the most number of questions that I've had at this event is really, why is Colt here? Because, I mean, as you all know, we don't really own any subsea systems. But the last time I checked, I guess most subseas need to get to the metros. So in terms of the design of the network, really, on the metro side, obviously we're very focused on the metros. Obviously not just the metros, but getting from the landing stations down into the key data centers in any market that we operate in. You know, it's really nothing sexy, but we are very focused on putting assets in the ground, fiber assets in the ground, so that we can leverage these assets to be able to provide high bandwidth services to our end users. Our real focus is to get to the key data centers that the demand is, where the demand is. You know, in Japan, the Ad Tokyos, the Equinixes of the world, and you know, the Mega Eyes in Hong Kong. But, and also obviously in Europe, we're getting from the landing stations to various different data centers. But we're also implementing a lot of technologies implemented by our partners. We're implementing CDC next year so that we can be able to leverage some of the flexibility that we get out of those technologies to be able to provision bandwidth more on demand and be able to restore systems quickly.
Thank you. And now looking at the data center, Nanang, with the increasing move to put the subsea plant effectively back in the data center, how do you see that affecting the design from your perspective of your network, your data center? What are the implications?
Okay, thank you. My name is Nanang Hendarno. I'm from Telkom Indonesia International, or TELIN. TELIN is an international business arm of Telkom Indonesia. Currently, today, we deliver our international traffic is around 4.4 terabit per second with the growth of 50%, more than 50% year on year. So we are facing difficult design in our network because we have to catch up the very high demand of the traffic. Especially in the near future, there will be 5G and IoT and probably Industry 4.0 that requires connectivity and data centers closer to the customers. And I see that our submarine is still a major infrastructure that we require to connect all data centers from centralized data center to regional and to access data center. Because in the future, with the low latency requirements for 5G, they require at least 5 milliseconds. It means we have to bring our data center closer to the access. That also needs connectivity that can be provided by submarine cables. But in the other hand, we also, the customer needs not only high bandwidth, but also low latency, high reliability, and flexible bandwidth. And also instantly upgrade of the capacity. As you know that today we cannot easily upgrade our capacity, especially in the consortium. It takes around 6 to 9 months to upgrade the capacity, but in the future we cannot do that. We have to think how to provide such capacity easily in the future to adapt with the customer's need. That's my thinking. Thank you.
Thank you. And thinking of the future then, can anyone comment on where they think we'll be in 5 to 10 years with technology and design? Sorry.
You want to take a crack at that one, Tim? 5 to 10 years. So higher spectral efficiency, better prime power efficiency, more of a mesh network architecture. You know, when I look just the comments from Colt, he said, look, we don't own submarine cables, but you have networks, and those cables are key components of it, and they think at a network level. So I think you're going to find more of that network level thinking going on. I think you will see the emergence of the network as the a piece of the programmable platform. This is, you know, my kind of connect, compute, and store builds the cloud, and then you add to it sense and act, and that's your Internet of Things. That kind of value chain that, you know, you have to have connect everywhere. That's your air, right? Everybody wants air to breathe, right? You have to have connect, but then you kind of work yourself up that stack of connect, compute, store, sensing, and acting. If you can close that loop, then you can add some real value. So I think that's the general trend that's going to drive a lot of what we do.
So I have sort of two parts. I want to echo what Steve said earlier. You know, when we talk about network, we talk about, you know, NIC to TOR, to leaf, to spine, to aggregation, to backbone router, to transport, metro, continental, subsea, and then back. So the network is not any one piece, it's the actual end-to-end connection. 5 to 10 years, so there's two pieces. One, I think a lot of the SDN, the software control and orchestration, will become much more mature. There's several initiatives. I mean, people have been approaching this for a while, but I think you're starting to see fruition in terms of, particularly in the metro and terrestrial networks, where it's become really prevalent, because that's the majority of the use case in the network, you know, the number of metro ports dwarfs the number of subsea ports in the world. And so you tend to operate there first. So I think in 5 to 10 years, you're going to see the extension of the tools that were developed in the metro and the terrestrial networks extend to the subsea networks. And this echoes the, what is NetConf and what is Yang and what are those models going to be? And I have a question there, that it's great that there's maybe a standard, but the customer base seems to be all over the place in what they want to do. So how do you manage that?
Well, until the customers kind of rationalize the market and say, and get some agreement both on, let's say, software protocol standards as well as photonic part standards, packaging standards and interface standards. We have to serve the various demands. I do think over time there is the opportunity to get some convergence and agreement, even if what it turns out to be is we've got to create a superset of what's out there. But getting to the point where there is commonality over time is a good thing. And I'd even go back to the physical parts. You know, the reason that you know, RJ45 is so low cost and it's the same all over the world is because we got one agreement around how to do it. We need the same thing for some of these interface standards and such, and then you can really drive for some, you know, really good economics, because the scale on a global basis is huge. When you have to divide it by 4 or 5 or 10 and say I got to have 10 different varieties of things, that just makes it cost more for everybody.
Somesh?
Two important considerations from the design perspective, from the future perspective. I think the wet plant design, I think that should be future ready. And when we are putting the submarine cable, we are putting it for 25 years under the water. So can we design the wet plant which is future ready and which is able to cater to the future traffic patterns or maybe the traffic requirement? If not, so can we design a cable which the life is not 25 years, maybe less at much cheaper cost? So these are the two things I think we need to think over from the future perspective.
Thank you. Andrew?
The biggest change in the last few years has been the move from consortium cables to spectrum ownership at either fibre pair or a partial fibre pair level, which has allowed operators to have their own SLTE. And that's what's really driving the ability to move from systems to network. Because now you have destiny in your own hands, you can turn up capacity whenever you want, you can move capacity around. If you have cables that are constrained on capacity, you can put the latest technology on that and move the older hardware onto another cable which is a lot more spectrum rich, you might say. And because the modulations are software settable, you can reuse that hardware even, it's not specific to a particular system. So that underlying building blocks of having spectrum and allowing a network then allows the automation, the SDN controls to allow you to automate the capacity. To have spectrum allows you to be able to do bandwidth on demand. Having multiple cables where you have that level of control lets you move capacity between systems under failures, which allows that sort of optical restoration. So that's probably the biggest fundamental change that's sort of allowing us to move to a network.
Thank you. Are there any questions from the audience for our panel?
So my name is Febrian from TELIN. Talking about the SDN implementation in submarine, so how actually operator get most of benefit regarding interaction with other platform like SD-WAN, MPLS, and another on top of application? Because one of mission of SDN is removing complexity and reducing the cost. But it seems it will emerge some complications and potentially bringing another cost for operator. So what do you think?
I'm not sure I caught all of it, but I think you're asking about MPLS. And one of the things that we use it the most for is actually configuration and network information. So it's about declarative push to the devices. And I'll give you an example. If we have a situation, let's just say we have a future state where we have a network with a WSS or maybe a switch in it, and we choose to make a change to the SLTE equipment, what I want to be able to do is have a configuration push both to that hardware to tell it, maybe I need to reconfigure because I want to change the BU to point in a different direction, and I need to move or maybe perhaps migrate some of the wavelengths because I have wavelength blocked on that other portion of the branch. So a lot of it is around automation of the configuration of the devices in the network, and then a topology that is available for all the other tools based upon that information. So there's confirmation of what the topology of the network is and the declarative push of the information out to the devices, be it through an API or directly onto all the chassis and platforms. Then at the higher level, then you get into how is the IP network actually using that underlying physical connectivity. But the topology is the fundamental piece that allows everything to stack on top of it. If you don't know what the topology is, you can't build an automation to move your circuits around. Hopefully that answers your question.
Any further questions?
I'm Pradeep. My question is regarding the submarine wet plant part. There are two options available. One, we can have a large number of cores which operating in C-band, or lesser number of core working at C plus L band. Where the actually industry is moving, I think it's C plus L is getting predominant, or is it that more number of cores operating in C-band, and that enables more operator to share the cable? Thank you.
So I think this is really the why spatial division multiplexing question, right?
Yeah.
I actually have a question. I don't think the monitors are on up here. I'm having a real hard time hearing what the audience is asking. Are the monitors on up here?
So was the basis of your question why spatial division multiplexing works at all? I mean, why is that of interest?
No,
No.
One is that the repeaters that we put on the subsea network is C-band, so that reduces the cost. But at the same time, we have the option to lay the repeater with C plus L band. That's the additional repeaters that goes in, right? In that case, the number of cores can be brought down. So both options give the same capacity. So where the industry is actually moving, it's moving towards C plus L type concept, or is it that more number of cores just operating in C bands?
Okay, so you want to go first? Well, mine is just C-band. The C plus L, this all goes back to it's electrically power constrained. So if I do a C plus L implementation, typically I use more power to pump both the C and L band than I would if I were just going to pump the C band. And so as a consequence, now there's things you can do about, you can call it pump farming or pump sharing, where I have, I didn't mention this earlier, but everything that we do going forward is going to be like 4 diodes pumping 4 fibers. For a long time, the industry state of the art was 2 pumping 2 or 2 pumping 4. Much more resilient architectures with 4 pumping 4, or perhaps even distributing it more, 4 pumping 6. In either way, you could do a C plus L in that configuration or a C only. It just works out what's the power envelope and how many of those can you fit into the repeater body.
I mean, the reason SDM might, let's see, a larger number of just C-band systems looks attractive is when you build broadband optical amplifiers, they're relatively power inefficient. You have to pump them hard, and the gain profile of erbium is such that you whack off the gain peak and get it to flatten out. If you actually said, if I can take the energy that I'm basically wasting by flattening the amplifier and just use it to make more amplifiers, you actually may do better. Right? That's the reason that people are really interested in it. And so there's that trade-off between, how much energy I have to put into the cable at all to make it work, and can I just light up more C-band amps that aren't as broadband and as powerful as I would if I had this very broadband C plus L, but I may get better overall results. So there's an optimization process that you can go through. That's what's driving, I think, the interest in it.
Somesh?
Just a small comment on that. From the operations perspective, we have to be very careful, and whether we are choosing between SDM or C plus L, because it's a long-term a decision, and the way the technology is developing, we have to choose the right technology. Otherwise, like say from the feature perspective, it becomes difficult for cable to be managed.
I want to make one more, and Pradeep, I have one other comment there, and I hadn't thought about it. The whole idea of multiple large number of fibers pairs is that you operate in a linear regime rather than getting up to the trying to push the top and operate in a nonlinear or at the top of the power hunt. I'm not sure that we actually have had a proposal from a vendor that showed a C+L linear power profile and how that compares to just C. So if they're out there in the audience, perhaps that's a food for thought for how that bakes out in terms of how many, maybe you only do 8 fiber pairs and you did C+L, but they're linear, and that corresponds to the equivalent of 16 if there's because one of the problems with multiple fibers is there's some mechanical challenges to how many fibers and amplifiers and things can you put into the repeater bodies. So that's an interesting point, and I think maybe we'll take that up a little further.
We were talking yesterday, Tim and I, about the mechanical issues. So if you have a system with a WSS BU and you have 32 fiber pairs in it, then the number of Rodin boxes you're going to have hanging off the back of your BU is huge, and that's something to think about in the catenary while you're laying the cable or doing a repair. So there's sort of added complexities that I would sort of request the vendors to think about ways of integrating things and modernizing the technology so we don't have mechanical problems with SDM. Are there any more questions? Okay, well, thank you to our panelists today. It's been very interesting, and thank you for your attention.
Well, can I make one other? I think we have 9 minutes left, right? Is that correct?
Yeah.
Yeah, so I didn't get the other point about the network of the future and some of those. And so I want to make the comment that the first coherent deployment I did on a submarine network was in 2010. So since then, the SLT has made dramatic, enormous differences. I think it's perhaps needs to take a breather now for the next set. And what I'd really like to see in the future too is some other changes, because I don't think that the wet plant itself has evolved a lot. And one of the things that I think is useful to talk about is that there's a lot of other architectures that you could to implement. We spent a lot of time at this meeting talking about permitting and some other things. We're investigating, looking at doing sort of a distributed feeder network off of coasts so you could build out passing territorial waters. Perhaps I deploy day one 24 pairs of fiber out to a place where I have maybe dual conductor cables out to a BU that allow me to connect multiple transoceanic cables from there to avoid all of the permitting process. So it's sort of one, and for one set of permitting processes, I get 4 cables across the ocean. To do that, there's some things that I think we need to go look at what the power industry does for power transmission and cables. I think you can take some of those ideas and extend them to what we do from an optical transmission standpoint. Because again, right now it's about how much power can you put into the repeaters. So there's that. We've talked a little bit about other conductors. I want to bring that one up too. One of the things that at least Facebook is pursuing is changing what do we use for the conductor in the cable itself, and looking at using aluminum rather than copper for a number of reasons. I guess there's some disagreement perhaps out in the audience about whether that's a viable solution or not. But in terms of the price volatility and supply chain, aluminum is a much better choice than copper. It allows you to save a lot of money. You can reduce the DCR of the cable, and it's something that people haven't done recently, and we're going to go look for that. So I'd like to see some improvements in the wet plant itself, because that's a place where I think the SLT has really outstripped the changes in terms of what the wet plant has done. So that's for the future. I'm hoping to see some of those kinds of ideas implemented in the water. I don't know if anybody else has any other thoughts on that one.
I think that's a great note to end on. Thank you, Tim. And I'm just pleased that no one mentioned the word drones. So thank you for your time today.